So this is our solving absolute value inequalities notes. Remember from our human number line, when we had values that were less than our number, this was all the people between the positive and negative end of that number. So for example, the absolute value of x being less than 2, that's going to be all of our values between positive 2 and negative 2. And this does include 0. So on our number line, we have all of our numbers between positive 2 and negative 2, and we write this with a singular inequality. So x is in the middle, the positive number is on the right, the negative number is on the left. When we have the absolute value being greater than a number, we are going to have two separate parts of our answer. So again, thinking back to our human number line, if we had a number that's absolute value is greater than 2, this is going to be all of our numbers bigger than positive 2 and all of our numbers less than negative 2. So going off to positive infinity and going off to negative infinity. So because there's a gap between these, we have to use two separate inequalities. So x is bigger than the positive number or x is smaller than the negative number. So what tells you what kind of answer you're going to have is the inequality symbol, if it's greater than or less than. So starting with example 1 here, the absolute value of x minus 5 is less than 2. This means, because it's less than, I'm going to have a singular inequality. So what's inside my absolute value goes in the middle. The positive number goes on the left. The negative number goes on the right. So x minus 5 has to be between negative 2 and positive 2. Then to get x by itself, I want to add this 5. And because I'm dealing with an inequality like this, I have to also add 5 on the left and on the right. I have to do it in all three places. So my end result is that x has to be between positive 3 and positive 7. And then graphing our x values on a number line, that's 3 and that's 7. I'm going to have two open circles, and it's going to be all of those values between 3 and 7. Okay. Example 2, I have that the absolute value of 3x minus 4 is greater than 5 or equal to 5. So this means I'm going to have two inequalities. So what's inside my absolute value is greater than positive 5 or equal to positive 5, or what was inside my absolute value is less than or equal to negative 5. So this is just a two-stepper to get our two values. So we have that x is less than or equal to negative 1/3, or x is greater than or equal to 3. So again, graphing this on our number line, it's going to be closed circle now because I had that or equal to, and all the numbers bigger than 3, so it's going off to positive infinity. And then negative 1/3, I'm just going to kind of eyeball that. Again, it's a closed circle because it's got that or equal to, and it's going off to negative infinity. So those are our x values. Then the last one on this page, the absolute value of 2 minus x over 3 is less than or equal to 0.01. So because this is less than or equal to, that means I'm going to have a single inequality. What's inside my absolute value is going to go in the middle. On the right is the positive value. On the left is the negative value. So again, I want to get x by itself, so we're going to subtract 2 from the middle, the left, and the right. Okay, and then lastly, I want to get rid of this 3, so I'm going to multiply by 3, and I need to get rid of this negative. So I'm going to multiply by negative 3 to do that all in one step. Apologize for that bell. So if you'll recall, dusting off those cobwebs, this is actually positive, sorry. Negative times negative is positive. when we multiply or divide inequalities by a negative number, that's actually going to change the direction of our inequality symbols. So over here, they were both facing to the right, and now they're both facing to the left. So because I multiplied by -3, it swapped that direction. And I want to rewrite this going from least to greatest, so just going to swap this to go from 0.597 to 0.063, or 6.03, excuse me. Okay, so these mean the same thing, but when we're reading a math statement, we want to go smallest to largest as we go from left to right. On to the back side. We're determining if these values are solutions for the inequality. So starting with this first one, the absolute value of x is less than 3. Is 2 a possible solution? Is the absolute value of 2 less than 3? Yes, so that is a possible solution. X is -4. The absolute value of -4, that is not less than 3, so that is not a solution. Absolute value of x minus 7 is less than 3. If I plug 9 in there, that gives me the absolute value of 2, and the absolute value of 2 is less than 3. So yes, 9 is a possible solution. Now -4, that gives me the absolute value of -11, and that is not less than 3. So -4 is not a solution for that one. And then lastly, the absolute value of x minus 7, this time greater than or equal to 3. So when we plugged in 9, remember that gives us the absolute value of 2. That is not greater than or equal to 3. So 9 is not a solution for that one. And then again, -4 would still give me -11. The absolute value of -11 is greater than or equal to 3. So -4 is a solution for that last one. Okay. Then these next two are just practice graphing on our number line. I find that it's easiest to put it as an inequality first and then use that to make your graph. So we're looking for all real numbers that are between 2, greater than 2, and less than 5. So that's what that would look like as an inequality. So this helps me to see, okay, I'm going to go from -2 to +5. They're both going to be open circles, and it's just going to be all of those numbers in between. Then the next one, all real numbers less than or equal to 4 or greater than 7. This tells me I'm going to have two separate inequalities, that or that separates them. So the first one, less than or equal to 4 or greater than 7. So again, this tells me closed circle, and it's less than, so it's going off to -infinity. Open circle, going off to +infinity. Last couple practice problems. The absolute value of y is less than 4. This tells me it's going to be a singular inequality with what's inside my absolute value in the middle, which is just y, positive number, negative number. And y is already by itself, so I don't have to do anything past that. Then on the next one, before I solve this, I need to make sure I'm getting my absolute value isolated on the left side. So I'm going to add 2 to both sides. So the absolute value of 12x plus 5 is greater than or equal to 9. So that greater than or equal to tells me I'm going to have two separate inequalities. So 12x plus 5 is greater than or equal to +9. Or 12x plus 5 is less than or equal to -9. Greater than the positive, less than the negative. And again, this is just a two-stepper. So x is greater than or equal to 1/3, or x is less than or equal to -7/6. Again, I want to make sure my absolute value is by itself. So I'm going to divide both of those sides by 2. So the absolute value of x plus 4 is greater than 4. That again means two inequalities. So x plus 4 is greater than 4, or x plus 4 is less than negative 4. And this one is just one step. So x is greater than 0, or x is less than negative 8. Okay, last one. I need to move that 7 over first. And then divide by 5. And it's less than, so that tells me it's going to be a single inequality. What's inside my absolute value goes in the middle. Positive value on the right, negative value on the left. Subtract 18 from the middle, the left, and the right side. And then divide everything by 4. And we can just leave this one in fraction form. We're going to get that x is between negative 19 over 4 and negative 17 over 4.